Hello, everyone. My name is Dave Hart. I'm with Internet 2's research engagement team, and it's my pleasure to introduce to you today Monga of Lawrence Berkeley National Lab. He is Executive Director of ESnet and Project Deputy for the American Science Cloud, and he's here to tell us today about the Genesis mission and the American Science Cloud. So, Inder, thank you.
Hi, everyone. Oh, this works. So thank you for coming. I know it is end of the day, but I just want to see if there is a raise of hands on who has actually heard of the Genesis mission. Oh, there seems to be a lot of people. OK, so that's good. So I'll make sure that there is time for Q&A. So as you go through this, please keep in mind. I wanted to start with a few slides just to introduce a little bit about Berkeley Lab and DOE, because I feel in some conversations that there may not be full awareness of what DOE does, what its mission is, and Berkeley Lab. So this is a picture from the Advanced Light Source or the cyclotron at Berkeley Lab. And this building and this national lab, Team Science idea, was created in 1931. So Berkeley Lab was the first national lab in the US. And if you see this person with the dotted arrows, the white dotted arrows, that is Oppenheimer. And the person in the glasses in the center sitting down is Ernest Orlando Lawrence, on whom the lab is named. So, but if you saw the Oppenheimer movie, he was the one who ran Rad Lab and decided not to join the Manhattan Project directly. And Oppenheimer was the one who did. But the thing that has stuck in DOE is the idea of team science. It's like all of us, engineers, administrators, finance folks, business folks, everybody comes together to make science happen. And I think that is something that you will see reflected as we go in the Genesis mission and the American Science Cloud. Now, just for saying, this was 46 is when the cyclotron was being built on the hill. And this is what it looked in a picture from 2011. I don't have a latest picture. I took an older picture to show how that place has transformed. So you're most welcome to come visit this. Now, the national labs are funded and run primarily from something called Office of Science. And the Office of Science is a part of Department of Energy. Department of Energy is much more than Office of Science. But the mission there is to deliver scientific discoveries with major scientific tools to transform our understanding of nature, but to what purpose? To advance energy, economic, and national security of the United States. So that is the goal, that is the mission, that is the overarching mission that encompasses all of us that work with the Department of Energy. Now, something that is the best kept secret is it's the nation's largest federal sponsor of basics research in the physical sciences. And it sponsors research at hundreds of universities, national labs, and other institutions. And at some point in time, the number I saw was it funds around 28,000 graduate students in the universities. So that is why it is the nation's largest federal sponsor. And it runs and operates at the national labs and at university. FRIB is at Michigan State, the best facilities to keep America at the forefront of discovery. So other than research, it funds instruments. And that's what it does. So it funds research, it funds instruments. And ESnet is one of those 27 user facilities. So that's kind of how we tie into the big picture. Now, just if you look at the national labs, these are the national labs plotted on a map of United States. And the color code basically describes to you which facility belongs to which area of research within the Department of Energy Office of Science. So for example, the top one on the right-hand side is Advanced Scientific Computing Research. These are supercomputers. So there is one at Lawrence Berkeley National Lab, there is one at Oak Ridge, and there is one at Argonne. So that's kind of what it says there. But there are two of the same color at Lawrence Berkeley National Lab because in addition to NERSC, ESnet is there that is funded out of the same organization. So that's how this is organized. So you see light sources, in Slack, the LCLS, the, and the, I think SSRL. There is one in Argonne, one in Brookhaven. So you can see all the color codes and the user facilities that are distributed across the national labs. And General Atomics has a D3D fusion reactor, and you see that there as well. So this is a map of user facilities, and it's a US-wide map, and they all need to be connected by the network. So ESnet is the DOE's data circulatory system that connects all these national labs together and also brings instruments, remote instruments, data from remote instruments, like the Vera Rubin in collaboration with AmLite. It gets it from Atlanta, and the Large Hadron Collider, which we build all the way to Geneva as CERN as a site. So that is what we do, and I think what we are is this data is the stage for an AI science platform. So that's kind of how we see ESnet as being part of the DOE ecosystem. Now I'm going to do some throwback time. I'm going to go back to Grace Hopper's lecture, August 19, 1982. She gave this lecture at a three-letter agency called the National Security Agency, NSA. And this was declassified and put online, I think a year ago, and there was a big splash on that. Now, she's an amazing computer scientist. She was one of the one who drove this field. She was in the Navy. And I'm going to play this video. I'm only playing a 5-minute clip. It's a 1-hour video. So I'm only playing a 5-minute clip. And I would like to draw your attention to listen to it, because things can go pretty fast. So here it is.
The importance of that piece of information in making decisions. No work, no research has been done on the value of information. We've completely failed to look at it. And yet it's going to make a tremendous difference in how we run our computer systems of the future. Because if there are two things that are dead sure, I don't even have to call them predictions. One is that the amount of data and the amount of information will continue to increase, and it's more than linear. And the other is the demand for instant access to that information will increase, and those two are in conflict. We've got to know something about the value of the information being processed.
So she didn't predict. She knew that data would increase more than linearly in 1982, and that was not even a prediction. And this is where we are. And we need insights from that information instantaneously as human beings. So these are the two things that, to me, are driving what AI is doing today. DOE has vast amounts of scientific data that they produce from all these instruments, and scientists need information on what that data is actually saying in terms of science immediately, whether it be a new material that they put in the X-ray crystallography or did a simulation run. They want to know what that data means. And the instruments are producing more data than we can humanly understand. So think of the data that all these instruments, this 27 user facilities are producing. And this is not a new thing for the DOE. There was an AI for Science report after a whole bunch of town halls written in 2020. That report is available for anyone to use. The link is down there, but you can search for it. There is an AI for Science, Energy, and Security, so expanding it across other DOE areas of interest. And that was a report written in 2023. So the fact that we want AI to understand and process this data to get insight from the data have been something that has been a constant theme for a long time. So this is not just an instantaneous change. So that leads to the Genesis mission. So Genesis mission is a presidential exec order which was signed on November 24th. What is it? So it's a national initiative. It is led by Department of Energy, but it's a national initiative. It is for everyone in the nation to build the world's most powerful scientific platform to accelerate discovery, strengthen national security, and drive energy innovation. And these are the three themes you will see repeated when they choose the problems to solve, what to go after. These are the three things. It's to accelerate scientific discovery, strengthen national security, and drive energy innovation. Now, what are they doing as part of this mission statement? So it's not a project, it's not a funding, it's a mission. And that's something I want people to understand, because I think everyone confuses the name as, oh, there's going to be funding. But it's a mission. That means funding will come in many different ways through many different agencies for this mission to succeed. So what it is going to do, it's going to develop an integrated platform. And I've tried to highlight some of those keywords so you don't have to read the whole thing, that connects. But I think the better thing than connects is that integrates supercomputers, experimental facilities, AI systems, and data. And that's what it is doing. It is integrating things that we have had with us for a long time. And what is the goal for that? Is to double the productivity and impact of the American national research and innovation within a decade. So it's a very well crafted. So if somebody ever has studied SMART goals, this is kind of an example of an excellently written SMART goal. In 10 years, double the productivity and the impact of scientific research through this process. Now, they did sit down, they did an RFI, all of you responded on what are the national science and technology challenges that should be considered as part of this platform. So they came up with 26. Again, the report is online. You can go read them. There is a one page for each one of them. It talks about how AI can help. I mean, I couldn't put all of that information here today, but these are some of them. And they're not just focused on technology. It is reimagining construction and operation of buildings. It is about nuclear energy that is faster and safer. It's about critical mineral supply. It's about quantum. It is about fusion. It's about operations from a security side, from nuclear deterrence to nuclear data and research, predicting US water for energy. So it is all the important problems that are stated as the 26 national science and technology challenges. And the goal is for this set of problems and the scientists that are working on these set of problems to define what they need from the infrastructure, what they need from the AI systems, and for them to easily access the capabilities that AI will provide. Now, this is not something that DOE wants to go alone. It is going to be working with industry and with academia, and that is the intent. Some of you, I think many of you were invited to the meeting in February 18th in DC to bring academia as part of this consortium. And it is about this consortium, and you can go to the website, is being managed by a third party. And from what I understand, the agreements or the membership agreements are all finalized, and it's a matter of them engaging and getting those signed so that we can bring this group together. The reason why we need these agreements is like any consortium. So if you think of Open Compute Platform, you need to sign an agreement. If you want to be part of ITUT or something, any organization, you need to sign a thing, because it's all about intellectual property, which private sector and academia do worry about. So what are they going to talk about? I think the 4 things that they have mentioned so far is AI model development and validation, data integration and standards on how do you get data sets across high performance computing and cloud infrastructure, and robotics and automation. So these are the 4 kind of areas of interest for this consortium. Now, the third pillar of the Genesis mission is American Science and Security Platform. And that platform consists of the intellectual horsepower or knowledge in the 17 national labs, combined with DOE supercomputers, with an AI workflow from training, fine-tuning, inference to agents, working with data sets that have been collected over the last 30 to 40 years, accessible to anyone via an API. Now, that API could be an agentic API, could be a normal web-based API. All kinds of things are being imagined, but this is the core technology engine of the Genesis mission. So you have national science and technology challenges, consortium on getting a wide group of people who are interested in helping and solving the same problem together, and a core engine that kind of drives this conversation and innovation to happen. So this American Science Cloud platform, sorry, I'm giving a lot of preamble so you know how we got here, so that it helps knowing where things are going forward. So this was in the HR1 bill, that was a reconciliation bill signed sometime last year. And if The American Science Cloud, the project that I'm going to talk about, got funded from that, this OBB bill. So if you look at it, it is a system of United States government, academic, and private sector programs and infrastructures utilizing cloud computing to facilitate and support scientific research, data sharing, and computational analysis. It's about transformational models. It's about creating models oriented towards science, not oriented towards writing emails and research papers or looking at your documents or doing your travel, but it is focused on science and scientific data. So that's the difference on how do we create foundational models that can help do research. Now, again, it talks about accelerate innovation in discovery science and new energy technologies, and it was $150 million available till September of this year, targeted towards this stuff. So you must be wondering, how did they allocate this money? So this is how the money was allocated. So the American Science Cloud, the platform that I'm going to talk about, was a $40 million project. It came as a solicitation. The solicitation number is there, 25-3555, if you want to go look it up. And then there was one on ModCon, or transformational models, which was another 30 million, which is 3560. Each of the science offices was given 10 million to work on preparing their science and their unique data set to be able to leverage this infrastructure. And around 30 million, which I don't know how it has been allocated, was towards partnerships, things that you're seeing happening in Genesis Mission Consortium, I think in integration of academia, industry into this platform. So that is probably some of the money that is in the Genesis RFA, which is right now, I think, 293 million total, but that is some of the money funding some of that research as well. So how do we look at this AmSC? So what AmSC is the infrastructure that actually enables AI models or scientific AI models to run. Now, the something that is unsaid is the data in the middle. They're assuming that data exists because scientists have been collecting data for a while. And I think maybe this is not appropriate in the current price of oil right now, but it is the new oil. And that is, so basically, AmSC is a platform that leverages the data that exists to train new AI models to do good science. So what is AmSC? It's a first-of-a-kind integrated platform. So, national labs, just like academia, compete with each other for grants, and PIs compete with each other for grants. But this is different. This is everyone working together to build one platform. It's a common fabric that they expect everybody else to build on. It is built in a modular way, so you can have modular services and abstractions. And basically, anybody who has value to add can become part of the platform so that that value can be expressed towards making science be faster or better. And it is a science-focused platform. That means we are doing co-design. It is not meant to be engineers build it, and then we'll go try to sell it to the scientists. So if you look at the funding, who got funded from this 40 million project, every national lab got one project as part of this American Science Cloud project. So they're called infrastructure facilities. You can see the one in bold. These are the ASCA facilities, which are the core infrastructure partners. But all the science workflows that were critical science workflows across all the different national labs, even the applied energy labs, which is Idaho National Lab, NLR, and NETL, they all have a project, and they're all working to co-design this core technology engine. Now, I do want to say that NNSA got a parallel 115 million. What are they doing with it? Don't have visibility, but you can ask them if you are curious about that. Now, what is the scientific discovery that we want to enable? So infrastructure is compute, storage, and networking. We want to build on top of that AI services, model services, which is training and inference, and data services, which is curation and making data sets AI ready. Just to share a little bit about ModCon, the other project, which is kind of, I would say, a sister project. So ModCon is basically to create innovative new models, new AI models. So they have 4 core teams. They have a partnerships team. That means they work with industry. They define how we work with industry, how do we work with data with intellectual property constraints. So they are figuring out how do we actually work in this environment where data may be protected. Not all data is open. The data brokers and standards are talking about how should data be represented, what does AI-ready data mean, what does data curation mean, what standards that can be applied to that. Best practices for scientific workflows. You want to go from an instrument to a supercomputer or to a cloud to generate, what should that scientific workflow look like? And then cross-cutting AI capabilities, which is more math and everything that goes in doing more reasoning, or how do we know that what it is doing is the right thing for more transparency and all of that. So that's on the right side, they have their delivery, and one of the delivery is an agentic framework that we can deploy on top of the American Science Cloud. I'm going to skip this in time. So just from the org chart perspective, this project is led out of Oak Ridge. Gina Turasi is the ALD, or the Associate Lab Director at Oak Ridge. Arjun and Arjun leads the Oak Ridge supercomputing facility. We are deputies, and there is a lot of people from Oak Ridge and LBL that are in the leadership. We have 3 dedicated liaisons to the ModCon, our sister project. We have an industry council of people that supported our project when we started, and then a science council with 1 person from every scientific area of interest in DOE that is advising us on the co-design piece, in addition to the infrastructure partners. Then we have got kind of more like a work breakdown structure with leadership and multiple levels. You can see virtual organization. This is a federated identity, but not only in terms of authentication, but for authorization. How do you authorize people on what resources they should use? The interfaces, infrastructure services. I will talk a little bit more about that, but you can see it is comprehensive, and it's across all the labs that are contributing in building this infrastructure. So this is what the architecture looks like. I know I don't have a lot of picture for the tech geeks here, but this is what it looks like. So if you look at it, the goal is on the top level, access the services we're using something called the AmSC API, which is on the top. But you can have a portal, you can have that, and you can have agents all interacting with it in a certain way. So either a portal.amsec.gov or api.amsec.gov. You have got modular services there to be able to manage the translation between workflows to infrastructure. And then you have an IRI API to integrate various infrastructure. So if you are a supercomputing center, or if you have a large compute cluster or data and you want to make it part of American Science Cloud, all you have to do is put an IRI API on top, maybe deploy an MCP server, Model Context Protocol server, and you can then be part of that. Now you do your own authorization, or you follow certain authorization by your funding agency. That all is accessed by the resource allocation protocol that is at the bottom, which says IRI API in the gray box. And then you have intelligent operations, which is monitoring everything, virtual organization, that is federated identity and authorization, data catalog, data services, AI services, which include training, fine-tuning, inference, simulation, model services, which is model catalog. You can go search and get a model from outside, from someone else, database as a service, and many other things that are all being built as part of that. Now, how do you discover new resources? There is a discovery API and a workflows API as well. So this is being built right now, and this platform is actually being developed in the cloud at the moment for speed. Now, as I told you, this is 1 year program fund, so 1 year money. So it's almost like a sprint. So we started October 1, 2025, and we need to be done by September 30th, 2026. This is not a 5-year, 10-year program. It is not a long-term program. It is a 1 year sprint, and that is what you hear from many people, is that the team is running. So 3 months for getting federated access up and running. It is among a group of 5 partners that you see. 6 months to do science team onboarding. So scientists are using the APIs to actually run workflows right now. These are going to be demonstrations in mid-May to the AmSec leadership. So every science team that is being funded as part of an infrastructure partner is going to show a 10-minute recorded video showcasing how they have been using AmSec to do their science. So that is end-to-end workflows on DOE resources. And then in 9 months, incorporating and building an agentic framework on top, so agents can start doing that rather than science-written workflows. And then in 12 months, what we have is what we call a minimum viable product. Now, it will be pre-production. It won't be production ready. It will not be operationalized, but at least a pre-production ready, which links infrastructure partners, supercomputers, cloud service providers in a uniform environment for a scientist to be able to run whatever science they need using AI services, and that is a foundation for future expansion. Now, what happens there, we don't know yet. That story is yet to be written. But we are at the 6-month point, and I can tell you, because we have IPT meetings or integrated project team meetings every week with DOE, and every 2 weeks we bring a video of a demo of some scientists using it. There is a hackathons going on where scientists are coming together, spending a week and making this integrations work. So it is really powerful to see that happening in real time. So I'll give you some of the examples of what that looks like. So one example vignette, how to use the platform for data discovery and model training. So, I mean, examples could be developing a foundation model for networking, which many of you do, or developing a digital twin for fusion, or extracting where the particle is coming in from a high energy physics collision. So what you do is users can upload or query data tables in the lakehouse that AmSC is developing, the data lakehouse. Users can ask an agent to find similar data sets. So they can say, hey, I want more data like this, go search it and find it and let me know what data exists out in the open source. They register their model. If they have one, they can go search for one using MLflow or ClearML, and then they train the model. So what they do is they start a workflow for model training using the web interface or the API or the agent. But what happens under the hood, which is why this eases the effort for a scientist to get work done, is there is a virtual organization that provides tokens. There is a resource orchestration that identifies how much resources and which sites have those resources available. And there is a data movement that moves the data from what the data was found in the lakehouse to where the resources are available. There is a model services that does tracking of the experiment. There is at-scale services that do, provides a software stack at each of the sites. There is an IRI API that launches all those jobs, and intelligent operations that tracks the job execution and lets them know when it is complete. So that is the value we are providing the scientists. They don't have to put it all together right now. Right now, they have to go put all of this together using cloud services or whatever is offered by the university or in the national lab together themselves and operate it so everyone develops a snowflake. And that is what we are trying to avoid. Another example is how to use it for inference. So data is produced as an experimental facility. You register the data set with the data catalog, set the appropriate access permissions based on who is allowed to see the data. The intelligent operations with virtual organization identifies an appropriate AmSC size accessible to the experiment, moves the data, starts the inference services and performance. It could perform large-scale simulations based on the inference results, and then your results may get reported back into the data catalog available for the other researchers as well. And there are many options that can happen at that point in time. So what I'm trying to say is, for RFA, for the people that are responding to RFA, AmSC is a pathway to build on the DOE's integrated capabilities to access the facilities, data, software, and tools to accelerate the components of their workflows. And that's kind of how you could use it. In the interest of time, I've only 20 minutes left. I'm going to move a little bit quicker for the next few slides, but they're there available for you to review when you go back. So first is federated identity. We said that this was a 3-month goal. This was a common frustration for all the scientists. So when we started in October, everyone said, solve that first. So that is what became our first 3-month goal. You can do unified login across DOE supercomputers. That was not the case. I know you may be surprised. And that is something that is now working. Data services, so there are examples, pre-production efforts on data catalog, lakehouse, data curation, and data movement. We have integrated Globus as one of our data movement platforms as well in this platform, so we can use that as well. So that exists. AI services are being developed as we speak in terms of inference and model services and at-scale services. And we are providing cross-DOE and cloud compute access. So you can either run it in a cloud provider or run it on a DOE supercomputer. And you may be surprised, this wasn't the case before, but we have made it there with something called a model access gateway, an ability to move between those two resources seamlessly. So for people that are developing RFA, if they are here, you can call out the capabilities and how you can leverage this AmSec capabilities to accelerate your science. We can use it for easing movement or accessing across facilities, even though they may not be available right now. You can point to it in the assumption that it'll be ready for pre-production when you actually need to build it. And it will allow you to focus on the S&T challenges and not on enabling capabilities in the infrastructure. Now, people that are thinking this is a workaround to get allocation on DOE supercomputers, I'm sorry to disappoint you. You have to still do that application even if your proposal gets funded. That's a separate process. I told you about these infrastructure partners at every lab. There are names here, along with which infrastructure partners are there if you want to reach out to them, to partner with them in the national labs. So each of the names are there. And then in those infrastructure partners, there are scientific workflows and facilities and infrastructure, which is supercomputers, big computing centers, which are not supercomputers, but high throughput computing, and many other cloud access, cloud resources as well. And again, we are working as AmSec as the core Genesis platforms, so to be a fabric that people can build on, and it is not going to be limited to DOE, but given at this stage in the development, it is a little bit a small group of people building it so that we can then expose it and get more and more input, both in terms of infrastructure, data, and AI to happen using that platform. If you want more information, there have been 3 webinars so far. If you want to sign up for it or you want to learn more, there are a lot more technical details in those webinars. You can go to amsec.energy.gov. There is both introductory, and as we make progress every quarter, we are putting a webinar out saying, this is what we did this quarter, this is what we accomplished, this is where we are at, this is work still to be done. So that's what we are doing, and that's why you have one in November and one later in January that kind of gave you the first 3-month picture. Now I'll open it for questions. There are 17 minutes for questions, so there should be enough time for questions. I'm sorry I rushed through a few of the slides. If you want me to go back any of them, I'd be happy to do so, but I wanted to make sure there was enough time for Q&A. Thank you. Steve. Q&A mics, please.
Okay, so I'll speak up. So you talk about the sprint, the funding lasting for a year.
Yeah.
But it wasn't clear what happens after that.
Yeah, because I think it is not clear. But so, absolutely. But that's a good question. So I think everybody of you has listened to the president's budget. And Congress are the appropriators, so we will see what happens.
Okay.
We don't know. I think from our perspective, we do the best we can from what we know and what resources we have been allocated. So we are looking at an MVP end of September, and we'll have something that is working, that adds value by end of that year. And that's kind of what we are moving towards. What happens after that? Wait to be seen. Other question?
Yeah.
Hi.
Yeah,
sure.
Any relationship, if any, between American Science Cloud and National Research Platform?
There is no formal relationship, but as we integrate academic resources and academia into this as part of the consortium, I'm sure there will be a good way. We are talking informally to see how National Research Platform could become an infrastructure provider into AmSec. But again, these things are under development, so I think we have to just find the right time to engage with them. So I'm in constant conversations with Frank as well on the side. So definitely, we in the R&D community know both sides of the picture, and we know where good work is definitely going on that would benefit from being part of it. I think we have to just figure out what is the right timing to do that. Other questions? I can deal with silence. If not, thank you very much for giving me the chance and the opportunity to share this work with you. It has been quite an exhausting sprint so far, so thank you for giving me the time. And if you have any questions that you want to take offline, I'm happy to do that as well. Thank you, everyone.